Article 350.30b of the National Electrical Code, or NEC, outlines the support requirements for liquid-type flexible metal conduit, or LFMC. This section stipulates that LFMC must be securely fastened in place. The general rule mandates that LFMC be supported at intervals not exceeding 4.5 feet. Additionally, secure fastening is required within 12 inches from each box, cabinet, or fitting termination. The code doesn't provide a specific exception for vertical drops of LFMC. Therefore, even if the LFMC run is oriented vertically, the 4.5-foot support requirement still applies. There is also no specific exception for data cables contained within the LFMC. The type of wiring within the conduit, whether it's power conductors, control wires, or data cables, doesn't affect the support requirements for the conduit itself. If the LFMC is exposed along its entire length, meaning it's not concealed within walls, floors, or ceilings, the support requirements of the NEC must be strictly followed. This is to ensure the mechanical integrity of the installation and prevent the conduit from sagging or becoming damaged. Therefore, in the scenario described, where 1-inch LFMC drops containing data wiring extend over 20 feet from the ceiling to the equipment and terminate 6 feet above the workroom floor, securement is needed every 4.5 feet. To summarize the LFMC support requirements, firstly, understand the general rule which states that LFMC must be supported at maximum intervals of 4.5 feet. Secondly, consider terminations and ensure that LFMC is securely fastened within 12 inches of any box, cabinet, or fitting where it terminates. Thirdly, be aware that there are no exceptions in Article 350.30b for vertical drops, which means vertical runs must also adhere to the 4.5-foot support rule. Fourthly, the type of wiring inside the LFMC does not affect the support requirements. Data cables or power conductors, the conduit still needs appropriate support. Fifthly, exposed runs of LFMC must be supported according to the code. If the conduit is visible, it's subject to inspection and must meet the NEC standards. Sixthly, always consult the latest edition of the NEC and local amendments to ensure compliance. Local jurisdictions may have additional requirements that supersede or supplement the national code. When installing LFMC, consider the following best practices to ensure proper support and a professional installation. Firstly, use appropriate support hardware. Select clamps, straps, or hangers specifically designed for LFMC. Ensure that the hardware is made of a material compatible with the conduit and the surrounding environment to prevent corrosion. Secondly, properly space the supports. Measure and mark the locations for the supports to ensure they are evenly spaced and within the 4.5-foot requirement. Use a level to ensure that the conduit is straight and plumb. Thirdly, securely fasten the supports. Use appropriate fasteners, such as screws, bolts, or anchors to securely attach the supports to the building structure. Make sure the fasteners are rated for the load they will be supporting. Fourthly, avoid over-tightening. When tightening the clamps or straps, avoid over-tightening, which can damage the conduit or the wiring inside. Tighten the supports just enough to hold the conduit securely in place. Fifthly, inspect the installation. After installing the LFMC and supports, inspect the entire run to ensure that everything is properly installed and secured. Look for any signs of damage or stress on the conduit or supports. Sixthly, consider environmental factors. In environments where the LFMC is exposed to extreme temperatures, moisture, or corrosive substances, use supports and hardware that are specifically designed for those conditions. Consider using stainless steel or coated hardware to prevent corrosion. Also ensure that the LFMC itself is rated for the environment. To provide some more background, let's delve into why these support requirements are in place. Firstly, mechanical integrity. Proper support prevents the LFMC from sagging, bending, or becoming damaged due to its own weight or external forces. This maintains the physical integrity of the conduit and protects the wiring inside. Secondly, safety. Adequate support reduces the risk of the conduit pulling away from its terminations or falling, which could create a safety hazard for personnel or equipment. Thirdly, code compliance. Following the support requirements of the NEC ensures that the electrical installation meets the minimum safety standards and is compliant with local regulations. Fourthly, long-term reliability. Proper support extends the lifespan of the LFMC and the wiring inside by preventing stress, strain, and premature wear. Fifthly, professional appearance. A well-supported conduit run looks neat and professional, reflecting the quality of the electrical installation. Now, let's consider some common mistakes to avoid when installing LFMC. Firstly, neglecting support requirements. Failing to provide adequate support is a common mistake that can lead to code violations and safety hazards. Always follow the NEC guidelines for support spacing and hardware. Secondly, using incorrect hardware. Using the wrong type of clamps, straps, or fasteners can compromise the integrity of the installation. Make sure to use hardware that is specifically designed for LFMC and rated for the environment. Thirdly, over-tightening supports. Over-tightening clamps or straps can damage the conduit and the wiring inside. Tighten the supports just enough to hold the conduit securely in place. Fourthly, failing to inspect the installation. Not inspecting the installation after completion can result in missed problems or oversights. Always inspect the entire run to ensure that everything is properly installed and secured. Fifthly, ignoring environmental factors. Ignoring the environmental conditions can lead to premature failure of the conduit or supports. Always consider the temperature, moisture, and corrosive substances present in the environment when selecting materials and hardware. In addition to the support requirements, other factors should be considered when installing LFMC. Firstly, proper bending. When bending LFMC, use a conduit bender designed for flexible metal conduit. Avoid kinking or flattening the conduit, which can restrict wire pulling and damage the conduit. Secondly, secure terminations. Ensure that the fittings used to terminate the LFMC at boxes, cabinets, or equipment are properly tightened and sealed. Use appropriate lock nuts and bushings to protect the wiring from abrasion. Thirdly, grounding. Properly ground the LFMC to provide a low impedance path for fault current. Use grounding bushings and conductors to connect the conduit to the building grounding system. Fourthly, wire fill. Do not exceed the maximum allowable wire fill for the size of the LFMC. Overfilling the conduit can make it difficult to pull wires and can damage the insulation. Fifthly, protection from physical damage. Protect the LFMC from physical damage, such as impact from equipment or vehicles. Use conduit cords or barriers to protect the conduit in vulnerable areas. To elaborate on the grounding requirements mentioned, grounding of LFMC is crucial for electrical safety. The purpose of grounding is to provide a low impedance path for fault current to return to the source, which helps to trip the circuit breaker or fuse and to energize the circuit in the event of a fault. Grounding can be achieved by using grounding bushings and conductors to connect the LFMC to the building grounding system. Grounding bushings are special fittings that are installed at the ends of the conduit where it enters a box or enclosure. These bushings provide a secure connection point for the grounding conductor. The grounding conductor is typically a bare or insulated copper wire that is connected to the grounding system of the building. The size of the grounding conductor must be in accordance with the NEC, based on the size of the circuit conductors. In some cases, the metal enclosure of the electrical equipment can be used as the grounding conductor, provided that it meets certain requirements outlined in the NEC. The enclosure must be electrically continuous and have a low impedance path to ground. When installing grounding conductors, it is important to ensure that all connections are tight and secure. Loose connections can increase the impedance of the grounding path and reduce its effectiveness. It is also important to protect the grounding conductors from physical damage. Now let's shift our focus to wire fill and consider wire fill calculations for LFMC. Wire fill refers to the amount of space inside a conduit that is occupied by conductors. The NEC sets limits on the maximum allowable wire fill to ensure that the conductors can be easily installed and that there is adequate space for heat dissipation. To calculate wire fill, one must refer to Chapter 9 of the NEC. This chapter provides tables that list the dimensions of various types of conductors and the maximum allowable fill percentages for different types of conduits. The first step in calculating wire fill is to determine the cross-sectional area of each conductor. This information can be found in the NEC tables. The next step is to add up the cross-sectional areas of all the conductors that will be installed in the conduit. Then one must determine the inside area of the conduit. This information can also be found in the NEC tables. Finally, divide the total cross-sectional area of the conductors by the inside area of the conduit to determine the percentage of fill. The calculated fill percentage must not exceed the maximum allowable fill percentage specified in the NEC for the type of conduit being used. For LFMC, the maximum allowable fill percentage is typically 40% for 3 or more wires. If the calculated fill percentage exceeds the maximum allowable fill percentage, one must either increase the size of the conduit or reduce the number of conductors. It is important to note that the NEC also specifies different fill percentages for different types of conductors. For example, conductors with thicker insulation may have a lower allowable fill percentage than conductors with thinner insulation. In addition to the fill percentage requirements, the NEC also specifies minimum bending radii for conductors. These requirements are designed to prevent damage to the insulation of the conductors during installation. The minimum bending radius depends on the size and type of conductor. When pulling wires through LFMC, it is important to use a wire pulling lubricant to reduce friction and prevent damage to the insulation. The lubricant should be compatible with the type of insulation on the conductors. It is also important to avoid pulling too many wires at once. Pulling too many wires can create excessive friction and make it difficult to pull the wires through the conduit. In summary, proper support of liquid-tight flexible metal conduit is essential for ensuring electrical safety, code compliance, and long-term reliability. By following the support requirements outlined in Article 350.30b of the NEC, and by adhering to best practices for installation and maintenance, electrical professionals can ensure that their LFMC installations are safe, effective, and compliant with all applicable regulations. Remember to always consult the latest edition of the NEC and local amendments for the most up-to-date requirements.